Problem number 16. Two soap bubbles of radii are 1 equals 1 centimeter and are 2 equals 2 centimeters conjoined together in the air, such that a narrow bridge forms between them. Assuming the system starts in equilibrium, the bubbles are extremely thin, and that air can flow freely between the bubbles through the bridge. Describe the evolution and final state of the bubbles. Problem 17. A particle of mass m moves in the xy plane with potential energy, u as function xy equal negative kx square plus y square over 2, the closest point to the origin x equals 0 and y equals 0 during its motion was at a distance d, and the particle's speed at that point was v naught equals 0. Which of the following statements is true regarding the path of the particle, after a long time t much greater than d over v? Problem 18. A particle of mass m moves in the xy plane with potential energy uxy equals kxy over 2. If the particle begins at the origin, then it is possible to displace it slightly in some direction, so that the particle subsequently oscillates periodically. What is the period of this motion? Problem 19. Near the ground, wind speed can be modeled as proportional to height above the ground. This is a reasonable assumption for small heights. A wind turbine converts a constant fraction of the available kinetic energy into electricity. The conditions are such that when operating at 10 meters above the ground, the turbine delivers 15 kilowatts of power. How much power would the same windmill deliver if it were operating at 20 meters above the ground? Problem 20. The International Space Station orbits the Earth in a circular orbit 400 kilometers above the surface, and a full revolution takes 93 minutes. An astronaut on a spacewalk neglects safety precautions and tosses away a spanner at a speed of 1 meter per second directly towards the Earth. You may assume that the Earth is a sphere of uniform density. At which of the following 5 times will the spanner be closest to the astronaut?